Howdy! We're ready for Fun Chem 2, Chapter 15, Amines and Amides. Excuse me, dropped hydrogen atom. So, looking over here at Fun Chem 2, Amines, Amides, then the first thing we really got to look at on these is what is an amine, what is an amide, right? So we'll be learning how to name these, doing all kinds of things. But the first kind of thing up is this is all based off of nitrogen. So here's ammonia. That's our nitrogen. And so we'll start with our basic ammonia here. It's got a lone pair. It's a trigonal pyramidal shape. In other words, it started off tetrahedral, if I count for the lone pair. So tetrahedral shape. Alright, so lone pair up here. Now this, all we'll really be doing with amines and even with amides is replacing these hydrogens with carbons. Alright, so an amide, one of these will be a carbonyl, and amines will just be regular carbons. Alright, we can replace one, we can replace all, so in between. But this lone pair allows us to do all kinds of chemistry. This is actually a weak base, and it can absorb a proton. And so if I get a proton, here's my H with the positive charge, and it'll get snagged right onto that lone pair up there, and we get ammonium. So this will be a true tetrahedral ammonium. Remember, ammonia, ammonium, more stuff, bigger name. All right. So ammonium. Now it's got four things around it. All right. So that's our key to this chapter. Is this reaction that nitrogen with that lone pair is able to, we can see it's going to be able to hydrogen bond. It's got a lone pair. It's also got hydrogens. Nitrogen's more electronegative than hydrogen, so that'll do some hydrogen bonding. When I'm down here in ammonium, it's now going to have a charge. It'll have a positive charge here on the nitrogen. All right, and so that's the overall chemistry that we'll be looking at. All right, so let's go through some of our PowerPoints then. First thing we have to learn is this idea of primary, secondary, tertiary for our amines. All right, and the same idea falls for amides, but here's the problem. All right, when we did alcohols, we were looking at the carbon, and we said how many. So when I did alcohols, we said this OH, all right, how many things, how many carbons are attached to this carbon that's on it? So we had 1, 2, this was a secondary alcohol. All right. Now the problem is when we do nitrogen, it's based off of how many carbons are on it. So this would be primary. It would have 2 hydrogens on it with the lone pair, and secondary would have 2 carbons on it. So why is this a problem? Well, when I combine these and I look at something like this, and I ask what class it is, this is a very difficult thing for students. We look at the nitrogen, so it's the nitrogen we care about. We're looking here, and it has 1 carbon. This is a primary amine. Now this carbon happens to be secondary. It has 2 carbons on it, so this is a secondary carbon. So this is a primary amine on a secondary carbon. So if we were asking about OHs, it would be a secondary OH. But for amines and amides, we're looking at how many carbons are on the nitrogen. That question is missed a lot, and I have seen professors miss that when I go back and ask them about that. So primary and secondary, tertiary for amines, it's based off of how many carbons, in other words, how many of those, we're always thinking of this picture, how many of these hydrogens have we replaced with carbons? All right. Now we can even add in a fourth thing. So we get this idea of quaternary. All right, so quaternary. Now here it's caused a positive charge on the nitrogen. So nitrogen makes 3 bonds in the absence of a charge. If it has 4 things, it'll have a positive charge. It's sharing that lone pair of electrons. All right, so we'll deal with quaternary later, but primary, secondary, tertiary for amines can be a little bit complicated, and that's just because we count the things on the nitrogen, and it's counting the uh, carbons on it. All right. So if those are all just carbons, then and no carbonyls, they're amines, they're amides if they have a carbonyl. Right. So and then we get to this idea of an amino acid. So this is an amine here, and it's this particular one is alpha to this carboxylic acid. Right, so it's not an amide, there's not a carbonyl directly attached to my nitrogen. So this amino acid, we'll spend a lot of time on these. So we've looked at those a little bit. So this particular one is using the common and alpha amino acid, and we'll come back and look at that picture more. All right, so everything is based off of ammonia. The key is it is a weak base. It is capable of accepting protons. All right. It's also very polar, so we can divide this molecule in half right below the nitrogen. So the top part would be slightly negative, the bottom parts would be slightly. So if I come over and I look at my model, then when I take this, I can split it right between the hydrogens and the nitrogens. So this part up here is negative, this part down here is positive. Being polar like that means it's going to be water soluble. All right, and it can do some hydrogen bonding, not as well as water, but it does hydrogen bond with water. So it's so small of these means primary, especially primary and secondary, as long as they still have that hydrogen, then they have higher boiling points than alkanes. They're lower than alcohols because they still only have that one lone pair, whereas alcohol has 2 lone pairs, so it doesn't quite do as well. Tertiary amines cannot hydrogen bond with each other. They still have the lone pair, and so they can accept a hydrogen bond from water, but not with each other. All right. And so smaller than 6 carbons, water soluble. Same kind of idea as our alcohols. So let's learn about naming these. So IUPAC and common, they've got different naming systems. So we're going to have to learn each of these. And IUPAC says you're going to take the parent name and it must contain the amine. So let's get an example. So here's a compound, and it must contain the amine. So in other words, when I number this, part of it has to have the amine. So 1, 2, 3, 4, and then this will be my amine. So if I had some long chain over here, I need to have the amine as part of my chain. All right, now the amine is a side group off of this carbon. So I'll number this 1, 2, 3, 4. This would be butane. All right. Now we've got an amine attached. It needs to have the lowest possible number. It's not always at 1, but the lowest possible number. And so this is 1 butane. And we're going to drop this E, and we're going to add amine is our suffix. Alright, so this would be 1 butanamine. The AN from butane and then amine. Alright, we give the number for where it's attached, and then if it had methyl groups or ethyl groups on there, we would name those as well. But we still have this group up here, and this group is not attached to the main chain. It's actually attached to the nitrogen. And so if it's attached to the nitrogen, it gets a side group, then that is a methyl on the nitrogen. Instead of getting a number, it gets the N. And so I will have N methyl 1 butanamine. Alright, the methyl is contained on the end. You treat the N just like it's a number, so it gets dashes between words, and the N, and commas between multiple. So if I have multiple things on my N, I might have NN. Alright, so let's do another example. Oh man, this one's getting complicated. Alright, so longest chain. This one has 2 carbons. This one has 1. Off of here, I've got 1, 2, 3, 4. But I can actually do a 5 carbon chain. 1, 2, 3, 4, 5. And so if I number this 1, 2, 3, 4, 5, we can see it a little bit easier. And this is my longest chain that contains the N. The N is contained at 2. So 5 would be pentane. Drop the E. Add amine. Now this amine is contained at carbon 2 is where it's attached. So 2-pentanamine. This also has a methyl group at 3. 3-methyl, 2-pentanamine. Alright. And then it has an N group. It has a methyl. It also has an ethyl. Now sometimes you'll see people that don't combine the methyls. I typically do. So ethyl is going to come first by alphabetical, so N-ethyl. I now have a dimethyl, and so I'm going to go ahead and put 3, N, dimethyl. And it should be one word, so I'm just going to continue it down here. Maybe I can squeeze it in. And then pentanamine. Just enough space. Right. N-ethyl, 3N dimethyl pentanamine. Whew, man. Gets to be a problem, mostly because once we start learning the common naming system, it can be an issue when we're dealing with these, because the nitrogen, the amine, doesn't have to be attached at 1. So this one should be 1, 2. Alright, so instead of a methyl propyl, this is just a butane, and it becomes 2-butanamine. Alright, so this one, you can see they've got a methyl and another methyl, so it's N dimethyl with a comma between them, and 2-propanamine. So notice it's at the 2 position. That one's the part that people tend to miss. Okay. Now, IUPAC also accepts benzene ring with an amine on it, being aniline, and then 3-methyl-aniline, for instance. It would be a methyl group in the meta position here. Um, and so that's also referred to as toluidine. Toluidine. And so aniline you'll see more often, and these not so much. Now, common naming is one word with an amine suffix. It works a lot like ethers and esters, but it's got one word, and that can actually be a problem. And so you're going to name each group that's attached to the nitrogen, and so the nitrogen is that part that says amine, and then everything else is treated as a side group, and you're going to list them alphabetically and use di and tri. So it's typically the common is used when you have something really simple looking. But here's two things off of. I've got a nitrogen, it's tertiary. I have an ethyl group, so this is 1, 2, and I have 2 methyl groups. All right. Now those are going to be listed alphabetically, and so we're going to go ethyl comes first. Ethyl dimethylamine. We might see something like that. That would be trimethylamine. So something easy. You can see why the common is still used. So triethylamine, ethyl dimethylamine, ethyl methylamine, ethyl methylamine. Well, you can have a nitrogen with 2 carbons, 1 carbon. I've only got 2 bonds on this. It's going to have a hydrogen on it. Ethyl methylamine. And so the common system works really well for easy things, but it tends to get people confused when they're doing the IUPAC, just because when you're doing the IUPAC, the nitrogen doesn't have to be at 1, whereas in the common it does. Alright, so let's look at some medically important amines. So amphetamine is this one that has benzene ring and then a nice symbol to our amine. The methamphetamine you've probably heard of, and all we did was we replaced one of the hydrogens with a methyl. We just put a methyl group on there. Alright, so they behave very similar. Novocaine, so nice, easy. A little more complicated. We've got now a diamine, alright, and this is the active part over here. And then dimerol, so it's an amine. Now I've got ephedrine and pseudoephedrine. Alright. Now ephedrine and pseudoephedrine, this one, the difference is this one goes back in dashes and this one comes forward. And if I look at these with this amine, it's actually this same drawing as methamphetamine. Alright. We can see that it's not that far off. All you got to do is knock off the OH off of this carbon, and then you've made either something based off of ephedrine or pseudoephedrine. And this is why you have trouble finding pseudoephed, is because people were doing this very simple process to get rid of that hydroxy group and to make meth. Now, if you were doing this and you got the stereochemistry wrong and you made it just like, instead of like you were trying to make meth, but you started off with ephedrine, you would actually make something that I've been told looks, smells, tastes like meth, but doesn't do anything to your body. I still wouldn't smoke it anyway. So a lot of these are important amines. We could also add over here fentanyl, and so you want to be careful about amines. We always I like to joke around with my wife that we want some enes, I-N-E, and so um, you know, caffeine, nicotine, uh, so um, so lots of things end in enes, and we always say the things that are bad for you that make you affect how you feel are end in enes. All right, so that's these amines. All right, so the main chemistry of amines is that they are bases, and so even when we change out these hydrogens, they still keep that same chemistry, and they are weak bases, and that is our major uh, chemistry for these. And so we will be having to name the ammonium salt here. All right, and so if we have this as a base where it has uh, gained a hydrogen, all right, and so it's basically like ammonium, you're going to name the amine and then you add in the suffix ammonium, all right, and so it's very water soluble. And so when I go pick up a bottle of medication, um, it may have the name of the drug and then .HCl, and so we use this to increase the water solubility of things, all right. Um, and so it's now that it's polar, it'll be or ionic, it'll be extremely water soluble. All right. Heterocyclic amines, and so uh, that lone pair, as long as you keep the lone pair, it is still basic. All right. And so alkaloids, for instance, are heterocyclic amines, and they have very specific um, tastes and structures. All right. Now, amides, fundamentally different than amines because you've got a carboxylic acid part and you've got the amine part. So not only do you have that carbonyl, but the carbonyl came from a carboxylic acid, and so we have to split those two sides, and that will greatly affect the naming of these. All right, so carboxylic acid uh, we usually use instead of, so let's say I wanted to make an amine with this carboxylic acid, and I wanted to, I don't know, add just react it with NH3. Instead of using the carboxylic acid itself directly, this reaction sort of works, all right? But if I can put the acid chloride or an acid anhydride, those are way more reactive. And we'll get the same reaction. And so now we can see that this half here came from our acid, and this part came from our amine. All right, so when we name these, we have to keep up with which side's which. The carbonyl is your acid side. All right, naming amides then a little bit tougher just because of the difference here. So we'll start off with our IUPAC naming. The root name is based off of the carboxylic acid. So you'll name the carboxylic acid just if it's the acid. And for IUPAC, it'll end in oic and then the word acid. You're going to drop all of that. That means you still have, you've named the alkane, you dropped the E, added the oic, so you still have that AN part here. Then you add this amide. All right. So when they named this one was so it was ethane because it's two carbons, and then it was ethanoic acid, and then it became ethanamide, right? Ethanamide. So it was ethane, and it has amide, all right? And then anything on the nitrogen, just like when we did amines, now they get the N rather than a number. So we better practice a couple of these. So I'll put 2 nitrogens there just to make life a little easier for us. So we've got a carboxylic acid here. 1, 2, oh, sorry. 1, 2, 3, 4, with an ethyl on it. So our carboxylic acid would have been a 2-ethyl butanoic acid. And then I'm going to take the oic and acid off and put amide. And then now we also have nothing on the nitrogen, so that's it. It's 2-ethyl butanamide. 2-ethyl butanamide. Alright. Well, this can be a little confusing. Because let's say I want to name this. This group has 1, 2, 3, 4, 5, 6, 7, 8 carbons. Whereas this group has 1, 2, 3 on it. Alright? You may be tempted to make this your parent chain, but this is the parent because of the carbonyl. That is our acid side. And so it was propanol, propanoic acid, and it becomes propanamide. And then we have 8, so this is N-octyl propanamide. No space. N-octyl propanamide. So doing the common names, you're going to use your common names for carboxylic acids. So the common names for the carboxylic acid. Give me just a minute. I'll take my lab partner out. Howdy, welcome back. My lab partner had a problem with his safety goggles. Must have been fogging up on him. So we were talking about amines and amides, and so we're looking at amides, and we said for IUPAC, you name the acid side, and everything else is a side group. And so the acid side, you name the acid, you drop, can't see anything I'm writing, you would drop the oic acid and add amide. And the key to this is the acid is the root. The acid is the key to all of this. Alright, so for the common system, all you really have to do then is you name our acid using the common name. Alright, so FAPBV, and then we're going to replace the ic acid. So remember, it doesn't have the O, so you're going to get rid of the ic acid and you're going to put amide, just as before. Other than that, it's the same as IUPAC. Don't forget, they're going to use alpha and beta and so all that good stuff. So let's look at this one. 1, 2, 3, 4 carbons. So butyric acid becomes butaramide with an ethyl group on the end. So this is N-ethyl butyramide. One word. All right. And so the common name system on this, it's really about just dropping the ic and then the word acid. All right. So we had some examples here. You keep up with it. Notice that the acid portion, the carboxyl group is still number 1, and the number 1 for the anything that's off of these, if you had, say, a side group off of a side group, then one is still what's attached to the nitrogen. All right, and that's really what I care about for the amines and the amides, is learning how to name, so IUPAC and common for both of those, and then knowing that they're bases, all right, and knowing how to uh, um, make them more water soluble by adding some acid, and so you get this quaternary amine. All right, so that'll wrap up our discussion for amines and amides. They're pretty fast. All right, catch you on the next one.